Let's go through an example of graphing the basic polar equation r equals cosine theta. The first step is to create a table of values that satisfy the equation, just as you would do when graphing an algebraic equation. Here's the start of a table of values that satisfy our equation. It contains the more familiar angles for theta. With a calculator, you could input angles in 10-degree increments to obtain more points and produce a smoother curve. Now let's plot these 5 points on a polar coordinate system. The first point is 1 unit from the pole and at an angle of 0 degrees. The second point is almost 9/10 of a unit from the pole and at an angle of 30 degrees. The third point is about 7/10 of a unit from the pole and at an angle of 45 degrees. The fourth point is a half unit from the pole and at an angle of 60 degrees. The fifth point is 0 units from the pole and at an angle of 90 degrees. Notice how the 5 points plotted so far seem to form a semicircle. Indeed, if we plotted several more points in the interval with theta between 0 and 90 degrees, we would clearly see that a semicircle is formed. Let's continue by finding some values for r when theta is greater than 90 degrees. Here are 4 new points. Notice that all of the new r values are negative. We must now remember how to treat negative r values when plotting these points on our polar coordinate system. If you recall, we must reflect these points through the origin. To do this, we make r positive and add 180 degrees to the angle theta. Therefore, the points actually plotted are those shown here. These points are located in the 4th quadrant, although the original theta was an angle in the 2nd quadrant. Remember, this is because r was negative and the points were reflected through the origin. Again, notice how the points seem to form a semicircle. If several more points are plotted for angles between 90 and 180 degrees, the resulting graph is the smooth semicircle shown here. This